Welcome to the podcast. Today I have my two good friends, Chris and Roy. Give us a brief background into yourselves. Chris, we'll start with you and tell us what you do for Zero Gravity.
Yeah, sounds good. It's great to see you here, Jax. So I'm Chris. I graduated MIT recently with a degree in computer science, mainly focused on computer systems and AI research. So in the course of my time there, I worked at a few of the top AI labs, some focusing on seeing if we can find cancer when it's metabolizing, when it's getting ready to spread and kill a person with AI models to be able to detect those sooner, be able to spot those earlier, and hopefully save some lives. And then also at Mosaic ML, which is a kind of corporate LLM. It's GPT-3 for 500K for your enterprise. I worked on the research and system side there. And now at Zero G, I'm helping Michael and Roy and the team build out the AI research capability. So how do we push the edge? How do we push the edge of state of the art to bring some of these farther out decentralized systems to a place where they're more reality and real world value?
Absolutely. And now Roy?
Thanks, Jax. I joined Zero Gravity as the head of strategy and brought about 10 plus years of experience in venture capital and entrepreneurship. So before Zero G, I was at Longhash Ventures, Hashkey Ventures, and Lightspeed Venture Partners, investing across deep tech, including blockchain. Back then, blockchain was tucked under deep tech, and now, of course, it's a vertical of its own right and might. Before that, I was an entrepreneur, funny enough, in enterprise AI. Before AI was cool, back then it was called ML, and delivering model as a service to customers like Tesla and McDonald's, helping them modernize their supply chain. So these days, I'm working closely with Chris and the rest of the Zero G team to help commercialize our technology and bring in the community as we go about it.
Awesome. Well, today we're going to be talking about the intersection of AI and blockchain. So, Roy, talk to us, and we'll stick with you. Talk to us a little bit about the importance in today's tech landscape, and what specific areas do you think the audience should really focus on that are like very synergistic between AI and blockchain?
So AI is poised to change the course of human history. We're already seeing early signs of AI being interweaved into our everyday lives as a co-pilot when it comes to coding, when it comes to creative generation. And for a global scale technological breakthrough, we need global scale compute infrastructure to support the proliferation of it. And we also need global scale coordination network. And across these two vectors is where blockchain comes in to help decentralize the backend. So, for example, some of the early proving points we're seeing in decentralized inference, along with blockchain's capability in verification, is going to power us to make sure that every community member that contributes to the creation and training of models is going to get properly rewarded. And once we hit that milestone, I'm very excited about where blockchain can bring value distribution to AI usage and head towards what I call programmable economy. So we're seeing early signs of that where agent-to-agent transmissions are already automated through smart contracts on chain. And I think in the next iteration, we're gearing towards an entire economy that can be programmable across different regions, across nation borders, and across community lines.
Absolutely. And talk to us a little bit about, for listeners that are new to the concept that aren't really as familiar with like how AI would even integrate with something like blockchain. Talk to us a little bit about how things like smart contracts actually set the stage for things like AI integration and how these things can be woven together.
Well, so I'll give a funny example. You know how we've been talking about DAOs for a very long time? But the A in DAOs had always been kind of missing. It was never truly automated. It was just a lot of people involved. But now it's possible. Now, for example, with Autonomous launching their governor agents, we're actually able to help communities be staying staying at the forefront of the evolution and governance of their chains by leveraging agents with smart contracts that can process natural human language in the forums and vote on chain accordingly, and have those outcomes be presented back to the forums in a full feedback loop. So we're seeing early proving points when it comes to leveraging AI agents with smart contracts.
And kind of sticking with you, and then we'll bring in Chris. I know the audience is probably like, hey, where's Chris? Let's talk a little bit about some of the core ways, because you mentioned agents, that AI is being used on the blockchain as it stands today.
Personally, some of the use cases that I'm excited about using AI for blockchain, when you look at a lot of these adversarial attacks or things like wallet drainings, where someone comes in, gets the keys to your wallet, submits a fraudulent transaction, you can use AI to help mitigate a lot of these, or add an extra check of sanity on top, in a way that if it's programmable and it looks at a lot of the data before allowing one of these transactions, or says, hey, is this really you? Something like intelligent 2FA. I think that's got the potential to help address a lot of the real world problems that happen with blockchain. And then the other thing that you get, in some ways, an AI is like increasingly evolving towards a intelligent human, where, because it's defined by code, one of the things that you can actually do, it's like being able to have a human that you trust and a human that you can program and point at a specific task. Now, of course, if any of you have read Vitalik's post on AI, he points out that it's important to be careful with how much do we use these things as a human, and it's absolutely right. So maybe you can use this to program more efficient schedules, something like fraud checks, etc. But it's not at a place, it's not interpretable enough, and there aren't enough guarantees to fully trust this system. But it lets you get ahead of the curve on a lot of optimization steps.
And there are a lot of, important terms that go into something like AI. And, for people that are relatively new to the subject, talk to us a little bit. They may have heard of things like machine learning, natural language processing, computer vision. Talk to us about how these things are integrating into something like blockchain, or have the potential to integrate into something like blockchain.
Yeah. So you've got AI, ML, computer vision, natural language processing, as you said, kind of, and then hundreds of kind of sub buzzwords within that. So when you look at computer vision and computer image generation, what that's good at doing is taking a prompt of some kind. Maybe it's text, maybe you give it another image, maybe you give it a bunch of data, and then it converts that to an image. When you look at natural language processing, it'll learn a task that you define it, that you define the model on and train the model on. Where with something like blockchain, I think one of the tasks that you could do is, hey, I've got this blockchain trace. Can you spot the fraudulent transactions? Or and you can use a combination of like a natural language model, maybe an image model, maybe you define your own input-output scheme so that you get a model that's really, really good at this. Where then another thing is, if you can take, say, the text generation models, so something like a GPT, and you can put it on chain, that enables like a different way and different payment rails for paying for the response, right? Where right now it's all routed through OpenAI or Anthropic or whatever type of system. But if you can mix and match and use a blockchain to combine different entities models and different, even small entities models, small entities data, and small entities compute, then you open up a whole new space of what it's possible to do and get paid for doing in terms of making these models and in terms of using these models.
Yeah, I'd like to build on what Chris has touched on small entities of data, small entities of compute. When you sort of look at what you mentioned about natural language processing, machine vision in aggregate, we're gearing towards a future where agents are able to process information from the world that humans operate in And in many ways, they're going to achieve like sensory parity with that of humans and become an active member in our community. And one thing that I'm very excited for blockchain specifically to bring is how do we personalize the experience with these agents? How, if they see, they can tell an apple is an apple, they can tell an orange is orange, but how do they know if Jax, for example, you like apple more or orange more, and make some intelligent decision making on which one you will buy, and then make that payment on blockchain and fetch it to you? That sort of like preference transference could be much better realized with blockchain in bring your own data. So right now, all of our data is gated behind the walled gardens of big tech. So we're not able to train our own personal agents that know ourselves the best and act on our behalf. But slowly we're seeing efforts with data DAOs built on top of blockchains that will allow the ownership of our own data, funny enough, our own data back in our own hands, and thereby training much more personalized and preference aligned agents.
Yeah, just to piggyback off of that, how do you kind of see that working? Because if we think about our current data, a lot of it's stored by, we'd say like a Facebook, a Google, people that are doing heavy ads tracking. Do you think that, I don't know, maybe we'll take all of the data that's on our phone and then be training our own AI models off of that? Talk to us a little bit about how you see that kind of future potentially being realized.
It's going to come in a couple of waves. We're seeing early signs of data DAOs. For example, Vanna, Grass, and OpenLayer are three projects that are pulling together millions of users' data and monetizing it on their behalf, so they can first get rewarded for the data they contribute. And then second, once we have that data ported on the blockchain, then as an individual, you can go and pick up different pieces, say your data from LinkedIn, your data from Reddit, your data from Google, and then put it together into like a verticalized, more fleshed out profile of your entire history that then you can train personalized agents with.
Yeah, and I think that's a big reason why people are drifting towards things like Farcaster.
Okay, yeah, just to piggyback off of that, a couple of really interesting real-world use cases along this, real-world use cases and algorithms that kind of make this more feasible. One was speaking with Pratik at NUS a couple of weeks ago. He's a student of Don, famous Berkeley professor, Don Song. But one of his students, they went off and they got what's called a graph neural network. And they actually said, okay, we've got 2 million, 10 million, don't know the exact number, but we got a bunch of distributed devices. And now we're going to get these distributed devices to each contribute their data towards training a model that does better for recommendation tasks like the Google, like the Facebook. Are you going to like this orange better than that orange? And they found that it did substantially better than the centralized version in some key metrics, which is, it's by no means a production ready system, but it's an interesting glimpse of where the field could go. And it was actually practical in terms of things like data privacy and things like overall compute time, where that was a really interesting experiment to see. And then the other thing is, when we did these models for cancer detection, this data segmentation and this data siloing is a really big problem. Same thing goes for where your medical records are, where all of your data is kept, because it's medical records and things like, where's this MRI that I got at one hospital versus another. Where right now it's siloed, you can't get it from one place to another. And even if you want to access your medical records and give them to your newest doctor, it's really hard to do. So this is one thing where you see technologies coming up the curve of reality. And those could be really things like fully homomorphic encryption or other privacy preserving technologies. And those plus blockchain could be really impactful for actually keeping people safe, actually keeping people healthy. And then the other thing is, if those people can lend their data, say for the cancer prediction task, you get different results and you get better results when you train across patients from the US plus South America plus Europe plus Asia than you do when you just train on people from the US, when you just train on any one of those populations. So having all access to all of those kinds of data is super important.
And you also mentioned real quick homomorphic encryption. For anyone in the audience that's unfamiliar with what that means, I'll invite you to define it, and I can jump in as well if needed.
My 20-second shot answering that is computation over ciphertext.
People get concerned that their data is going to live on chain. So it's like, hey, I've got all of Royal's medical records and all of Jax's medical records living on chain. Isn't that relatively dangerous? Like, couldn't somebody just really look at our specific medical records? But fully homomorphic encryption allows us to essentially keep all of these things on chain, but have them encrypted in a way that only people with access can look at those specific records. And then fortunately, we have a real expert that should be coming in here soon to better describe what is fully homomorphic encryption. But it has a bunch of implications. Like if we're playing games on the blockchain, I don't want Roy to be able to see the cards in my hand. So we're able to encrypt those in a way that although they live on chain, it's not able to be read.
Oh, man. I like a good game. I would never take a cheat and try and look at your cards, Jax. But yes, I think I'm... Trust by verify. Yes, while I'm excited about homomorphic encryption, it is quite a ways away from implementation. When we look at computation over ciphertext, it is still anywhere between 50 to 200x, like sometimes thousands x more computationally heavy than the current kind of the computational benchmarks. So in order to achieve the same level of prominence and while preserving privacy, we're excited about the more immediate use of TEE, of collaborative snarks in zkML that could kind of preserve the same kind of secret hiding across potentially interest in misaligned parties, but still get a better outcome across the board that benefits the parties involved. I know we have some early results that we're kind of like scoping out and experimenting on.
Yeah. So cryptography as an enabler is huge, right? Because a lot of these cryptographic technologies give you provable bounds, give you provable guarantees on, what you can do and the kinds of security guarantees that you have. So in the medical document context, some of these methods, even if they're ridiculously high overhead, like 200 or even 1,000 or sometimes even 10,000x, it's actually monetarily valuable to be able to train it that way because you just couldn't train it any other way. And the upside is big enough to justify that additional cost. In terms of more practical approaches and low overhead approaches, you've got TEML for inference, at least. You've got a variety of solutions, things like TEEML, OPML, sampling ML, and even some people claim zkML, where just going through those TEML, the idea is we've got the chip, we've got the physical hardware, and the instruction, the manufacturer actually bakes in a set of instructions and bakes in a way to keep the inputs, outputs, and computation on the device hidden from the person who owns the device. So unless you've got something like an electron microscope or something, or a very high-level systems hack, it's going to be hard to get the data out of that TE. Now, this has a couple of advantages. It's very quick to run. You can trust it. It's very quick to verify that trust. So basically no overhead on something like an H100, basically no overhead on some of the Intel SGX chips, AMD's SEV SMP. But you're dependent on the hardware for that guarantee, where if somebody really motivated wants to hack it, and they own the chip, and you end up sending your data to that chip, there are ways that you could compromise the data. There are ways that you could, in theory, break that environment. Although it's very, very, very difficult to show in practice, and I think that the only successful hacks of these systems have been very limited in scope. So that's one end. Then you've got something like SPML, which is sampling, to basically construct an incentivization system around the inference layer. where you've got queries coming in, you've got requests coming in, like Roy is asking ChatGPT, what should I feed my dog tonight? And then that goes to one of the network participants' GPUs. And that network participant has to stake a certain amount of money stake a certain amount of money in order to answer that request. So it says, okay, you should feed your dog salmon, and sends that back. And every some number of queries, you've got a validator node that reruns that same computation. And if it turns out that the GPU providing the answer to Roy has lied, then it finds out enough money so that the expected value of lying on these queries is always negative, and the expected value of providing honest answers is always positive. Now, this is great for a number of reasons. One of which is, the number of TE is a fairly high-end, fairly expensive hardware security feature, where on the GPU side, which is what you really need to run these models, you only have them on NVIDIA's Hopper architecture. And they made, I think, 3 million of those chips last year. And it's not like we're getting too many more of those anytime soon. Where, in contrast, the inference side in SPML is much cheaper. You can run it on something like a 4090, where, just to compare the price tag on it, it's, I think, 60K.
2K versus 30K? Yeah.
Yeah. I mean, the H100 is actually more expensive than it seems, because, you've got a rig with a 3090, 4090 that's $2,000, $4,000. If you add in the chip plus the networking hardware plus the CPU plus all of the other shit that you need to make an H100 go, you're easily looking at 50 to 60,000 per chip. And they're good, but they're not that good. A 4090 is about half the flops of one of these really high-end chips. So SPML basically lets you federate it out to anyone, and it gives you a more well-defined source of truth mathematically, where in a TEE, you're dependent on the hardware manufacturer. In SP, you're dependent on an equation. And then you've got ZK, which is kind of the most expensive, but also probably the most reliable of these verification schemes. And for ZK, that's a lot of equations that I don't understand, that you use to generate what's called a succinct proof of knowledge. So a short version that the answer to the computation, and like the answer that you gave is actually that answer. Now, for context, for I think a single llama token back in March, that one of the forget the name of the project, but one project said, all right, we're going to take a llama model and we're going to run it in ZK. And I think a single token took at least 12, maybe 24 hours to generate and prove. And that's something where on a typical non-ZK node, you're looking at hundreds of tokens per second. And here a token is just a word. So it's much, 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 much more expensive. But you have some qualities that maybe you like for certain aspects of blockchain systems when you're running ZKML. Now, on the training side, what you're looking at doing there is basically taking one of these large language model training computations and taking it out of a data center, where in a data center, you've got really high bandwidth network. A single Blackwell chip will have, I think it's 200 terabytes per second worth of memory bandwidth, which is a lot. And then if you look at a desktop or something in one of these decentralized environments, you've got 5 gigabytes. So you have to figure out how to make that same computation be much less resource intensive on how it communicates and how it shares. And then on top of that, you have to account for, okay, I've got a bunch of nodes out there, and some of them I trust, some of them I don't. Maybe I even have some nodes like Meta, for instance, as an example, doesn't want a new big model. So they say, all right, I've got an H100, I'm going to put it on the network, and I'm going to sabotage every single computation that these guys do. Which historically in other types of at-home computing systems, people have done for no reason at all. They've done it because they want to look good for their friends. SETI at home had massive challenges with nodes contributing false values for no reason whatsoever. So in a large distributed AI case, you have to do a combination of things to mitigate the impacts of these nodes and make sure that the model that you get ends up being a good and properly trained one. And that's something where, one of the techniques that we're looking at is, okay, we've got these perfect validators. Let's say that we have perfect validators. They can rerun some parts of the computation. So I'm having a validator basically check once every 36, once every 72, once every n times. And if I catch you that once, I fine you enough so that it's not worth it, which is great. It disincentivizes cheating nodes. But then on top of that, you have to find out, I've got a cheating node. What's the maximum impact that can have on the honest nodes? And because you're running multiple steps of this computation and each step is dependent on the last, you really have to do a good job in mitigating those effects so that you can have some sort of mathematical bound in like the worst case divergence of the model. So the worst case loss, the worst case that a single cheating node or multiple cheating nodes, and even cheating nodes that are working together to sabotage the process. You have to be able to limit that impact dramatically. So that was a lot of things all at once. What made sense and what didn't?
Well, I think to the audience, depending on the technical nature, at least half of those things will make sense to them. But let's talk about something that I think will make sense to just about everyone. And let's talk about some of the practical examples of AI and blockchain that you guys may be excited about, and we can talk specifically about them. So let's talk first about AI agent portfolio management and see if you guys have any opinions on whether this will be something that will take off or is relatively something that's not too exciting.
Sorry, I'm not sure what that really means.
AI agent?
Like, is the agent making investment decisions for you, or are they like AI suggesting?
If you know what Wealthfront is, so it'd be like, hey, let's take. I'm a MetaMask wallet. I have 1,000 Tether, and it's going to say like, hey, we can do some level of portfolio optimization for your balance here. We can invest it in EtherFi. We can take that.
Yeah, I don't think it's uninteresting, but the improvement there might be incremental, because if we look at where we are in the grand scheme of things in the evolution of AI, predictive markets, using a variety of like algorithms, including random tree, including like traveling agents, have already been optimizing portfolio management for decades, right? So the wave that we're currently seeing is really on the generative front. So I think I'm a lot more interested in the cross-section of Web3 AI, where we leverage the now available generative reasoning capabilities that have been recently unlocked. That's the big wave that we're looking at.
And Chris, I don't know if you have any opinion on that specifically.
Yeah, I think that there are a lot of potential use cases for these LLMs especially in understanding the world, right? If you look at what these things do, or one of the things that they can do is they can take in a lot of text, a lot of even images, and hopefully video soon, and generate a compact and a well-represented understanding of that. Something that you can use in math to make decisions off of it, where if you can figure out how to properly leverage that to do some sort of trading or trading through better understanding the world in real time, I think that there's a lot of potential there beyond what you can do with ordinary systems. Like, we've all seen the headlines of like some celebrity having a similar name of a company, and the company goes up because the celebrity was in some movie. Hopefully you can avoid misunderstandings like that and even get more complicated steps, more complicated combinations to make sense of that. So I think that there's potential value there. I hesitate to say that the AI models that we have right now are reasoning effectively, and they're still terrible at math. So we definitely need a combination of techniques, and I don't think I think one of the things Roy and I have been talking about is what's the iteration front look like? Where any technology, you see a series of booms and busts and booms and busts, and it gradually gets more mature. Where I think the same thing will happen with AI, and we're going to have to push the capabilities of transformers a lot farther out if we want to see true reasoning, and I think that's going to keep getting pushed. But I also, there are some things you can do with them now.
Yeah, just kind of like double clicking on some of the areas that Chris mentioned. What are some like 0 to 1 usage of AI agents in trading that's been unlocked? For example, if they're able to process like images, and they're able to see the world as we have. Remember that one time when that passenger in Alaska Airlines noticed that the door got literally blown off, and so he shorted their stock? Was that insider trading? That's a topic for another time, but he profited handsomely from it because he was getting ahead of the curve. So the agents today, once the tooling matures around it, because right now they're really bad at math, they don't know when to take actions. They don't know when to initiate trading activities. They're not proactive in that sense. So we're a couple steps away until we can say, hey, deploy an agent onto YouTube, onto Google Satellite, and identify idiosyncratic opportunities like that, just like any other hedge fund will, and then drive my portfolio accordingly to take advantage of those trading opportunities. That's truly exciting.
Yeah, I 100% agree. And I think another area that is particularly exciting is potentially AI's ability to write code. I don't know if either of you have used Cursor AI. I don't know if that's allowed at the Zero-G offices, but even historically, GitHub's Copilot, I don't know if we think that, say, AI-driven automation in terms of coding or AI automation in terms of prediction of security vulnerabilities is an area that could be quite interesting. I don't know if either of you have an opinion on those.
Yeah, I have some seen teams that are leveraging AI to do smart contract auditing and on-chain hazard monitoring. The thing is, I'm very bullish on such technologies bringing incremental and marginal revenue to the companies that already are established in the security space. It is very hard to bring a new company 0 to 1. One, because the market in Web3 auditing and security is still quite small today. So, and two is because fundamentally the tools used for smart contracts using AI are not that different from the tools used for software auditing and software security in Web2. And so, you're not just competing with the other startups within Web3. You're sort of, as a newcomer, you have to compete with incumbents across the board. So net, we're going to benefit from it, but it may not be a 0 to 1 opportunity.
Yeah, I agree with that.
Definitely agree. And there's some pretty interesting cases, right? Pretty interesting cases both in Web3 and Web2 of these AI models successfully finding exploits. It's not like you type ChatGPT and then say, okay, where's the vulnerabilities in this contract? You have some pretty complex orchestration to do, so it's still you have to build the tool around it. But bullish on using AI to understand programs and understand where they'll maybe go faster, slower, or break. I think that's cool. And then that being said, if you look on the Cursor side, right, Cursor, Codium, all of these AI for code places, it's still making good devs better, or even making bad devs better too. But it's the difference between me spending a day writing a CUDA kernel and saying, okay, hey, here's a previous one, modify it a little. Okay, it works in practice. I can use this for research. Where it's a speed of advance kind of thing, rather than, I think, a quantum shift.
I like the idea of not having to write as many unit tests and having some AI do that for me, but I don't know if we're there quite yet, unfortunately. And then another popular topic, and this is maybe less in the AI space, but is essentially the change that blockchain and potentially brings to identity.
I would say is in blockchain with identity, identify humans across borders and have proof of humanity is one really exciting area where WorldCoin has done a lot of work in. What I'm also very interested in is once agents gain an ID for agents. I think that is an open space that has yet to seen a good solution in terms of time stamping, signature signing of the particular model instances, so that we could keep these automated models that are perhaps like acting on our behalves traceable and accountable by using the blockchain technology.
And when you say an ID for agents, what do you think that would specifically entail? Because I think most people would be like an agent might have a wallet and that could serve as their ID. Is there a specific thing you're thinking about in terms of like an identification for an agent?
Yeah. I mean, so that's maybe level set. Agents / co-pilots today are very much in the sandbox. And that is a function of several factors, including a lack of proper tooling, their unreliability and instability today. But looking sort of 5 to 10 years down the road, we're going to get to a state when tooling for agents are going to be much better, and when their behaviors are going to be much more reliable and predictable, and they're going to participate in an automated economy. So what happens, when an agent like comes up to your counter and tries to like sign up for a membership? What happens when the agent comes to try and buy a bag of apples from you? Who is this agent? Where do they come from? Do they deserve credit? All of these need to be answered. And I think because agents are inherently global, because they can traverse the world of software across the internet, it is going to be very, very challenging to keep them like confined within national borders. And so blockchain is naturally and natively and inherently a much better solution to keep IDs for agents on a global scale.
Yeah, and then I guess if your agent is created in the U.S., they have to pay U.S. taxes, and I guess we'll create all our agents in Singapore so they're free from the tax man.
Or Dubai while you're at it.
Or Dubai, all agents originating from Dubai. Breaking down some of the bottlenecks that exist with running some of these models on chain. Roy, I don't know if you have any insight into kind of some of the developments that Zero G is bringing to the ecosystem to allow more people to run AI on chain.
Zero Gravity started out as a provable and infinitely scalable data storage layer that can hold models and the data that they train on and build up traceability and provenance that way. Where we are headed is Zero Gravity is the first decentralized AI operating system that can help stitch together the different components across inference, training, and data, and thereby serving AI use cases, leveraging a global scale infrastructure for demand at a global scale.
Yeah, there's a lot of exciting innovations happening on the AI side, whether it be, making a available and useful TEEML toolkit, definitely implementing and again, making it really easily integratable from the AI serving framework side, where that integrates the TEEML, the OPML, the SPML, eventually probably the ZKML. And, I think that we've got a lot of resources going into the question also of there's all of this stuff that's out there, and all of this potential applications, potential value add that's out there at the intersection of AI and blockchain, where the way I see the work that I do is really how do we identify the noise from the bullshit, the signal from the noise, and then take the steps and add the techniques that we have to really enable those the signal use cases as opposed to the bullshit noise use cases.
Absolutely. And, finally, to wrap up, because you guys have been very generous with your time, talk to us a little bit about like people that are aiming to learn a bit more about, some of these technical concepts that we discussed today. Talk to them a little bit about like where you would recommend they go online to learn more and just kind of understand some of the things we're talking about today. I'll start with Roy.
Well, start off by following Zero Gravity, Chris, and my Twitter, where we post contents on the latest in verifiable and trustless AI usage cases. Then going forward, happy to share with the our audience here with our latest research that will be coming out in the next 6 to 9 months.
Absolutely. And what's your guys' handle on Twitter so they can find you?
Mine is 0x Roylu.
You know, when somebody prefaces it with 0x, they've been in the game for quite a bit of time. Now, Chris, what's yours?
I should get more active on Twitter. I don't really have a public Twitter, so I'll shoot that over to you when we start posting from that.
Awesome. Absolutely. Well, everyone go follow Roy, go follow Chris, and obviously go interact with Zero G on Twitter and go to their website to learn more, because they all have some exciting announcements coming in the next, well, honestly, exciting announcements coming all the time, but specifically Chris and Roy mentioned the next 9 to 12 months. So be in touch with that, and let's continue building the future of Web3.